Welcome back, everyone. So we are going to pick up where we left off, which I believe was getting router 1 into the mix here. So we're going to actually accomplish a few things here. So by adding router 1 to the mix, we are now creating a layer 2 and layer 3 boundary, if you will. So we've got our VLANs running between the switches, giving the PCs inter-VLAN connectivity. But now we need to start making the considerations and trying to figure out how we're going to build this network so that this site is going to eventually be able to talk to other sites. And again, that's where the layer 3 routing boundary starts to come into play. So we're going to accomplish a few things, but we're going to try to keep this simple. And again, we're going to just continually build upon this as we go. So I'm on router 1. Let's, first things first, give it a host name. Okay, let's do a show IP interface brief just to kind of level set. We can see that we've got 4 interfaces to work with. They are all administratively down. So the 2 that we're going to be messing with are 00 and 01. So let's continue to work up. So we're going to get a link between the switch and the router working. Now, if you recall from earlier on in the videos, I had made a comment about VLAN 100. And I said, maybe VLAN 100, excuse me, is a VLAN that's dedicated for inter-device connectivity or interconnects, or maybe some call it a management network. Call it whatever you will. But at some point in time, network administrators are going to need to be able to reach these devices to administer them or to monitor them, right? SNMP, Simple Network Management Protocol. We're going to need the ability to have network reachability to the actual device, as well as allowing the devices that are connected to them pass traffic through them. So you always have to make that consideration in your design. So we're going to go ahead, we're going to use VLAN 100 as the purpose of connecting router 1 to switch 1. And then we can also put an address from VLAN 100 on this switch to provide that layer 3 reachability. So let's go ahead and do that. Let's go ahead and we're just going to make each device, we'll start off with, we'll make the router .1, we'll make the switch 11, and we'll make this switch 12. It is what it is, doesn't really matter. So let's go ahead and jump into ETH00 on the router, and we're going to no shut him. Now, we are going to, actually let me jump to the switch, and let's do show VLAN brief. So we do not have VLAN 100. Let's go ahead and create VLAN 100. All right. And then let's go ahead and create interface VLAN 100. All right. We'll give it an IP address. We had said 10.1.0.11. We'll stick with our /24 mask as our key dictates, and we have to no shut him. Okay. Quick verification. Alright, we've got VLAN 100 now, looking good. Now we have introduced some kind of pruning on the switches, so we need to just validate that that VLAN is allowed to traverse the port channel, right? So let's just take a peek at port channel 1. Okay. So port channel 1 is not pruning on this side. So what we should see is when we do interface trunk, we should see that since we created VLAN 100, it is now allowed on the port channel, which it is. So that is a fantastic sign. So let's hop over to switch 2, and let's go ahead and create VLAN 100. All right, we'll go into interface VLAN 100. IP address is 10.1.0.12. Let's go ahead and no shut him. Quick verification. Okay, so now that's our only IP layer 3 interface on switch 2 at this point, right? We've just added a layer 3 interface to the switch. We've created the VLAN, and let's check the port channel. Okay. So we've got 100 is now allowed on the port channel. Okay, so we are not pruning. We undid that config at some point in time, so that's fine. So we're allowing all these VLANs to traverse between the switches. We don't care about VLAN 100 reaching these PCs, again, because it's just for network administration purposes, to have that VLAN reachability to the device, the network devices themselves. Okay, so now let's go back to switch 1, and let's take a peek at ETH01. So we see that it's not configured, right? So there's a couple ways to approach this. We can do more of what's called router on a stick configuration, which is make this link a trunk that allows VLANs to traverse it, and then we create what's called a sub interface on router 1. That is a way to do this, or we can do a no switch port on 01, which essentially allows that E01 to become a routed port as opposed to a switching port. There's pros and cons to either way. I think the easiest way for this demonstration is to make it a routed port. Like I said, there's pros and cons here, and we can demonstrate it both ways. I think what I'm going to do is I'm going to make another couple videos I'm going to add a site. I'm going to build it the exact same way, or make the topology the exact same way, but I'm going to configure things a bit differently to kind of show you guys, different ways to do the same thing, right? So let's go ahead and go into ETH01, and instead of doing a switch port mode access like we were doing before, and then defining a switch port access VLAN, or a trunk for that matter, we're going to go ahead and do a routed port. So what we're going to do is we're going to type no switch port. And now what that allows us to do is actually throw an IP address right on this interface. Okay? Actually, let's do this on the next one. My apologies. Because we're going to add complexity down the switch too if we do this. Let's go back to the router on a stick method. Let's turn this back to a switch port. Sorry about that. I just had a epiphany while I'm sitting here talking about it. This is why we do things live, because it makes it a little bit more interesting. So we're going to make this a trunk port. So E01, and we're going to say switch port trunk encapsulation .1q, switch port mode trunk. Let's just give it a description. We'll say it's the link to AR1. Okay, so so if we do show interface trunk, we can see that we should have a couple trunks now, right? We've got E01, which is the one we just made, right? Same encapsulation, same native VLAN. We haven't really got in the native VLANs yet. But we can see we're allowing all the VLANs on the trunk, which is fine. Same as the port channel. So that's perfectly fine. We're going to leave it like that for the moment, okay? Now we're going to go back to router 1. We're actually going to start to do things on router 1. So do show run interface E00. There's no configuration there. Now you might think that we need to put the IP address on E00, which if we did a no switch port on the switch, you would certainly do that. However, in this case, since we're doing more of a router on a stick design, we're going to create a sub interface, okay? So all we need to do is no shut 00, which we did up here, okay? So now that interface is enabled and ready to go, right? Instead of doing Ethernet 00, I'm going to do ETH00, and I'm going to hit the question mark. You can see that it allows me to use a dot or a period here. So I'm going to hit the dot, I'm going to hit the question mark again, and it says enter the Ethernet interface number. This is locally significant to whatever the administrator decides to make it. So in other words, you can make it any value between 0 and, whatever this is. 42 million, it looks like, something like, or 429 million. There you go. So We're trying to get VLAN 100 off this interface. So what you typically see in the real world is you take the VLAN that you're trying to make to pass to this device, and you just make it the same as the VLAN. There's no need to overcomplicate things. So we're going to create that interface. Now check this out. As soon as you do that, I've got this new interface that just showed up on my router, and it's in an up state because the interface that it's built on top of is in an up state. If I were to shut this interface, okay, it's going to have a negative effect on the sub interface. So just to kind of show you guys. Okay, see what happens there? So it's similar to the port channel where there's like a bit of a hierarchy. So when whatever you do to this this is not the sub interface. Whatever you do to this interface, whether you administratively enable it or disable it, it will trickle to the sub interfaces. And if you have more than one sub interface, they'll all go down. So just be aware of that. So let's no shut him. Okay. Now you can, by the way, if you just want to shut down one interface, you can still do that. So I can still shut down this individual interface, but just keep in mind if there's multiple subs under this one and you shut this one, they all go down. So that could be a bad thing for that could be a bad day for somebody if they don't know that. Okay, so one more time. We can see we're up. Now here's the magic command that you have to run. So let's hit the question mark and see what iOS sensitive help says. There's an encapsulation command. It says set the encapsulation type for an interface. So if you recall when we did the trunks, we did encapsulation.1q, okay? Well, we need to make sure that that matches between the router and the switch. So this is important. And now it wants the VLAN identification number. So we know that we're trying to pass VLAN 100 up to the router. So we're going to say encapsulation.1q 100. We use the iOS sensitive help. Looks like it's happy if we hit enter. So let's go ahead and hit enter. Do show run interface eth00.100. We can see that that command is now in the running config. Let's go ahead and slap our IP address on there. So we had said 10.10.1 for the router with the /24 mask. Okay. We know it's enabled. We know we've gave it a VLAN identifier. So we now see that that IP address is now assigned to the sub interface. Let's try a connectivity test really fast. So let's try to ping 10.1.0.11, which is switch 1. Okay, that's a good sign, right? So we ARPed and then we got our 4 pings. So if I hit the up arrow, we've now got all 5 pings successful. So we've now got connectivity between router 1 and switch 1 over VLAN 100. So let's hop down to switch 2 and let's see if we can establish connectivity all the way to him. Okay, so we've got our VLAN 100, right, is .12. We know that we have the trunk configured, which allows 100. That's good. We validated that on switch 1. So with any luck, we should be able to just hit our up arrow, change that to 12. And voila, we can see that we now have connectivity to switch 2. So this is a good way to, like I said, enable management, administration, CCNP, because you've now used a VLAN somewhat out of band from the production traffic that is only flowing to the devices themselves. So typically a best practice in real life environments, and we now see that we can effectively mimic that in a lab environment and make it a bit more realistic. So we're going to pause there and we'll pick back up on the next video.